In this video, we're going to see how to check equations that involve radicals. And this should be familiar to you a little bit, and we'll just do a little bit that's different in it maybe, and it should be quite easy. I've got two equations here to check. Let's do the first one first. It says the solution is -3. So we're going to start by assigning the value -3 to P. And then we're going to just look at what the left side equals and what the right side equals. And that can be done in your head too, but let's just go ahead and do it. And if they come out equal, then it certainly is the solution. And so let's store -3, -3, store for P this time, and P is over the 8. Okay, so I'm going to do alpha 8, and I'm going to hit the colon, which is over the decimal point, so that I can make a compound statement, and I'm going to put the left side in, which is the square root of P plus 3, alpha 8, plus 3, close parentheses, plus 1. And just hit enter, and you get 1. So the left side is 1, and then go to the other side and put the square root of P plus 4, alpha 8, plus 4, close parentheses, and hit enter. And you got 1 there too. And certainly left equals right, 1 equals 1, so it checks. So your solution is P equal -3. In solving the second equation, I got two solutions, 0 and 8. And so let's check both of those, but we can only check one at a time. So let's first store 0 for M and see if it makes the left equal to the right. Now sometimes, once you have hit rational equations, which you did in Module 10, the methods for solving equations are not foolproof. They can find all the answers, but some of the answers may not be real answers. They're the only possibilities, though. So we have to check all our solutions to see if they're real answers. And these may or may not be. I have not checked them yet. All right, so let's store 0. Store for M. And we have to use 0 because that's the answer we came up with. Alpha M is over the divide key, and hit the colon to make a compound statement, and let's put the left side in. We know the right side already, it's -2. So we'll hit the square root of 4M, which is alpha divide, plus 4, close parentheses, and minus M, which is alpha divide. Double check what we have. We stored 0 for M, and we put in the square root of 4M plus 4, and then we subtracted M. And we hit enter, and we get 2. So the right side is -2, and the left side is 2. This does not check. Okay? And so we try the second solution. And that is 8. And the way we do this is we just hit second enter, and that rewrites the statement, and we go over and edit what we were storing as our value of M, which was the first thing we entered, and we just put 8 in there. And then we hit enter, and it'll evaluate the left side. and it gives us negative 2. So we find out that when m is equal to 8, we get negative 2 equals negative 2. And that checks. So our 0 is really not a solution, and our only solution is 8. The next problem that we're going to look at is one with fractional exponents. I solved the open parentheses 8x plus 31, all raised to the 1/3 power plus 1 equals 0. And the solution I got was negative 4, which again may or may not be right. And so we're going to check it. And the way that we're going to check it is first we're going to let x equal negative 4. And that's the only excuse me, possibility that I had. And we already know that the right side is 0. So we don't really have to calculate that. But the left side had better come out to 0 too. So let's go ahead and do this. And we get, we enter it as negative 4. And we're going to store that for x. So store for x and hit alpha colon and make a compound statement, and then we'll put our left side in and evaluate it exactly as written. Open parentheses 8x plus 31, close parentheses, and I forgot about the parentheses around the fraction, so let me add that right now. And that's got to be raised to the, in parentheses, 1 divided by 3, close parentheses. And if the parentheses isn't around that fraction, it will not evaluate correctly. And then hit plus 1 and hit enter. And I'm hoping it gives us 0, and it did. And so we do have a valid solution here. 4 is a solution. Now we're going to look at the last problem that we're going to examine on the calculator for this module. And this is probably the most difficult too. It's the case of solving a formula for a variable when there are several variables in the formula, which is really just writing another version of the same formula. The original was r is equal to the cube root of 8u divided by pi f. And my solution was f equals 8u divided by pi r cubed, where u and r and f are all different variables, and pi has its value. And on the you do have pi right there on your calculator above the raised to power. So what you do in a situation is you look at the answer first, and you assign values to the variables on the right side so that you can figure out what value of f goes with them. So I'm going to pick values that I'm just going to pick values randomly here, and I'm going to let u equal 10, and I'll let r equal 7, and pi has already got a value, so I don't have to worry about that. And that's all the variables on the right side, so when I figure it out, I'll know what f is. So I do need a parentheses around the numerator and a parentheses around the denominator. And so let's figure out what f is. And then we're going to, okay, let's do it. So first we assign a value of 10 to u. So 10, store, and let's see if I can find u. It seems to be above the 5, alpha u. And hit the colon. And then we'll give the value of 7 to r. So 7, store, and r is above the time sign, alpha x. All right, and there's r. All right, and then we need another colon, so we're making this more than compound, double compound, because we have 2 variables. And now let's insert the expression, open parentheses, 8u, I forgot where u was. Okay, wait a minute. RS, there it is, above the 5. Close parentheses, divided by, open parentheses, pi again is right here, and it's use the second key for that, r cubed. R is alpha times key, and raised to the 3rd power, and close parentheses. And hit enter, and you'll see the value of f. Okay? Now we're going to need this value for f. So let's store that. And if I just hit store, it'll take the answer and store it for f. And so that's our value of f. And I might as well write it down approximately. F is approximately, put a little dot above that. There's many ways to say approximately. 0.07, but I'm going to store it exactly as it is. So I'm just going to put the whole answer in as f, because it really, and f is above the cos key, so alpha cos, and that's fine. And I think I'll put a colon. Okay. Alpha colon. And so that's now stored as f. Now I want to go, I know what r is. What we're going to do right now is we're going to go back to the original and see if when we plug everything into the right side, we do get the value of r, which was supposed to be 7. See if it makes a true statement. 7 equals the right side. So you go to the end first, and then you go back to the original with all those values you got. When you plugged in 10 and 7, you got a value of f, and we put them back in to the original statement. R is 7 is equal to, and let's see what the cube root is. So we have to go to math, and we're going to get the cube root, which is number 4, and I'm going to need parentheses here around the numerator and denominator in that fraction that's inside the cube root. So that would be 8u, which is alpha, I keep losing u, 5, close parentheses, divided by, open parentheses, pi, which is above the raised to power, and f, which is alpha, let's see, where's f? Cos. And close parentheses. And then if that comes out to 7, which I hope it does, all right, here I go. Wait a minute, let me make sure everything's done. Let me put another parentheses to close the cube root. Well, yeah, I can see right now that this whole thing has to be in a parentheses, this whole fraction, because, and it's not because it didn't. So let's go back and insert another parentheses around the whole fraction, and I'm afraid of order of operations otherwise. It seems like it inserted one. I need another one. Second insert parentheses right with that in front of that 8, and another one right at the back of this, at the very end down here, to enclose the whole, so that the whole everything under the cube root is in one parenthesis. All right, let's hit enter and keep your fingers crossed. And it came out 7, and I've had a good day. All right, so you want to look at this problem a few times and try it, and try some similar problems. And remember, you start with the final result and assign values arbitrarily to the variables on the right side, and that will determine what your left-handed variable is. All right. Good luck. All right.